Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. Stellantis is the world's fourth largest automaker, encompassing 14 brands including Peugeot, Citroën, Fiat, Alfa Romeo, and Chrysler. In 2024, global sales reached 5.42 million units, with compact SUVs forming the backbone of the company's success. As of today, many models such as the Citroën C4, Peugeot 308, DS3, Fiat 600, Alfa Romeo Jr., Lancia Upsilon, Opel Mokka, and Jeep Avenger have been launched in the market. These models are equipped with a powertrain that combines a 1.2-liter three-cylinder turbocharged engine, a 48-volt self-charging hybrid system, and a 6-speed DCT, dual-clutch transmission, all built on Stellantis platform known as CMP, Common Modular Platform. Furthermore, Stellantis has introduced a new platform called Stella Medium, which is being adopted starting with the Peugeot 3008. This platform will also feature the same hybrid powertrain as the CMP. This video explores the details of that powertrain. This illustration shows an overview of the hybrid system. An engine disconnect clutch and an electric motor are positioned between the engine and the transmission. By disengaging this clutch, the engine is disconnected from the powertrain, allowing the vehicle to run using only the electric motor. Engine starting and power generation are handled by a 48-volt BSG, belt-driven integrated starter generator. During launch and low-speed driving, the engine disconnect clutch is disengaged, and the vehicle runs using only the electric motor powered by the battery. When the vehicle's speed reaches a certain level, the BSG acts as a starter motor and starts the engine. Once the engine starts, the engine disconnect clutch engages, and the vehicle is driven by engine power. At this time, the BSG operates as a generator, charging the battery and supplying power to the vehicle's electrical system. When rapid acceleration is needed, the electric motor assists the engine. Even when the vehicle speed is above a certain level, the engine shuts off if the accelerator pedal input is low. During deceleration, the electric motor operates as a generator, charging the battery and providing regenerative braking force. The engine is a 1,199 cc, three-cylinder turbocharged unit, named PureTech. There are two variants available, one with 100 kilowatts and 230 Newton meters, and another with 74 kilowatts and 205 Newton meters. In a three-cylinder engine, each piston moves up and down with a 120-degree phase offset from the others. Therefore, a rocking vibration occurs in the fore-aft direction, centered around the number 2 cylinder. To prevent this, there are two methods: adding counterweights to the crankshaft or crank pulley, and installing a balance shaft that rotates at the same speed as the crankshaft. The PureTech engine uses a balance shaft system to cancel out the inherent vibrations of its three-cylinder layout. The first and second generation PureTech engines used a belt-driven valvetrain system, which led to reliability issues. However, with the introduction of the third generation in 2023, the system was changed to a chain-driven design, resulting in a significant improvement in reliability. The turbocharger is a VGT, variable geometry turbocharger. In conventional turbochargers, high engine speeds and heavy loads produce high exhaust gas pressure, which spins the turbine wheel rapidly and generates high boost pressure. However, at low engine speeds and light loads, the exhaust gas pressure is too low to generate sufficient boost pressure. A VGT is a system equipped with vane-shaped valves in the turbine housing that narrow the exhaust gas flow path, increasing gas velocity and allowing sufficient boost pressure to be generated, even during acceleration at low engine speeds and light loads. This engine is a Miller cycle engine. The Miller cycle engine is an operating method commonly used in hybrid vehicles. By closing the intake valve later or earlier than in conventional engines, it prioritizes fuel efficiency over power output, and the reduced power is compensated for by a supercharger. This channel offers a detailed video explaining the Miller cycle. If you're interested, please check it out. The link is in the description. Miller cycle engines in Japanese hybrid vehicles typically do not use superchargers. Instead, electric motors compensate for the reduced engine output. This is because systems such as CVTs, continuously variable transmissions, or systems with similar effects, can keep the engine operating in its most efficient RPM range. However, since the engine in Stellantis system operates across a wide RPM range, much like a conventional gasoline-powered vehicle, so their decision seems highly reasonable. The Transaxle houses an engine disconnect clutch, an electric motor, a 6-speed DCT, and a differential. Since the DCT has 2 clutches, this Transaxle has a total of 3 hydraulic multi-plate clutches. The 6-speed DCT is manufactured by Punch Powertrain and features a very unique mechanism that includes a drum-type shifting system and a planetary gear set on one of the clutches. We will compare the shift fork operation of a conventional DCT with that of a drum-type DCT. Conventional DCTs are equipped with actuators for the shift forks on both the odd gear shaft and the even gear shaft, and they operate independently. In drum-type DCTs, a single actuator can operate multiple shift forks. Since detailed information on the shifting operation of the 6-speed DCT could not be found, we will use the 7-speed DCT made by Punch Powertrain to explain it. These two transmissions differ in the number of gear steps and whether they include an electric motor, but their shifting mechanisms are similar. If you're not familiar with how a manual transmission synchronizer works or how planetary gears operate, we recommend watching these videos. You'll find the links in the description. Engine power is delivered to the outer shell of clutch 1, and clutch 1 is connected to gear set 1. An internal gear of the planetary gear set is integrated inside the outer shell. The planetary carrier is connected to gear set 2. The sun gear is connected to clutch 2, and when clutch 2 is engaged, the sun gear is fixed to the transmission case. When clutch 1 is engaged, gear set 1 rotates at the same speed as the engine. When clutch 2 is engaged, the sun gear is held stationary, causing the planetary carrier to slow down. As a result, gear set 2 rotates at a lower speed than the engine. In other words, in this transmission, switching the clutches changes the input speed to the gear sets. Synchronizer 1 is positioned between gear set 1 and gear set 2. 2 gears are fixed to the output shaft, and power is transmitted to the differential through one of them. Synchronizer 2 and Synchronizer 3, each with 2 gears, are positioned on the output shaft. In first gear, clutch 1 is disengaged while clutch 2 is engaged, and torque is transmitted along the path shown by the arrow. By engaging clutch 1 and disengaging clutch 2 in this state, the transmission shifts into second gear. Since the output from clutch 2 is reduced by the planetary gear, switching the clutches increases the output speed. Moving synchronizer 1 to the left puts third gear in a standby state, without changing the output speed. Disengaging clutch 1 and engaging clutch 2 shifts the transmission into third gear. In this transmission, it is not possible to shift directly from third to fourth gear, so the shift passes through fifth gear first. Moving synchronizer 2 to the left puts fifth gear in a standby state. Switching the clutches engages fifth gear, and moving synchronizer 1 to the right puts fourth gear in a standby state. Switching the clutches again shifts the transmission into fourth gear. Switching the clutches shifts the transmission into fifth gear. Moving synchronizer 1 to neutral and moving synchronizer 3 to the right puts 6th gear in a standby state. Switching the clutches shifts the transmission into 6th gear. Moving synchronizer 1 to the right, and moving synchronizer 2 to neutral puts 7th gear in a standby state. Switching the clutches shifts the transmission into 7th gear. Please note that the operation being explained here is for the 7-speed DCT manufactured by Punch Powertrain. Although the operation is similar, Stellantis hybrid system uses a 6-speed DCT integrated with an electric motor. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.